I've had several requests for more information on the pulse valve, so I thought I'd do a strip down today and give you some details on how I built this experimental pulse valve. Anyway, this is with it still kind of assembled, and give you an idea of roughly how things are put together there. The water inlet is on the side, and that is just a PVC coupling glued into the side of the PVC pipe with a hose bib adapter in it. In the bottom we've got a similar thing, another coupling glued in the bottom plate. The blue plastic is actually 6-inch water pipe used by the municipalities for water lines. Quite often you can find scraps of that at different projects. So I'll go ahead and take the top off and show you what's inside. Okay, now we've got things apart. You can see what it looks like here. The inside riser is pretty much level with the top of the main body. Now that's something that could be experimented with. I'm not sure whether it would work better with it higher or lower. This just happened to be where I started. And if we look inside there, you can see where the water inlet's coming in at about the 1 o'clock position there. And so all that happens is the water comes in, fills up the cavity, and with the valve material blocking the outlet pipe in the center, eventually the pressure builds up inside the valve where it lifts the or forces the diaphragm off the valve, and there will be once that valve opens, then the little bit of water that's available plus the entire column of water in the riser pipe basically rushes down the pipe and then sucks the valve closed again, and that's where you get the hammering action. So there's nothing that threads into that center coupling. I'm just using the top surface as the valve seat. And I'll show you a couple of the other parts here. This is just a plastic ring that is used to hold down the diaphragm. And this is the diaphragm assembly. It's just a piece of actually rubber pond liner, but something like inner tube material would be good. And it's just roughly cut to size. And you can see where the mounting bolts and everything go through it. This little spring assembly was actually a piece from Home Depot that is used to, there's some electrical track for hanging conduits from ceilings and stuff, industrial setting, and that's actually what this little bar is, and this little spring, it's meant to go into the channel, but it just happened to be lying on the workbench, and I thought, well, there's a good spring and something that's adjustable. And I put a little disc of plastic on top here, mostly to stiffen the diaphragm when it was opening and closing. And you can see I've turned that down a little bit so there's an angle in the center. So this thing basically slams down, and you can see it seals, this rubber seals on the top of that white plastic center pipe as the diaphragm moves up and down. This is pretty rough just being a standard bolt would actually be better if there were no threads on there. Eventually that thing going up and down is going to either wear the threads off or wear out the piece of flat bar I have, but for testing it, it worked quite well. And I've got the adjustment screws. Here you can set the height of the valve. So that's pretty much it. That's all the pieces there. We've got the riser pipe, the body, the diaphragm, batch of screws. Turn this over. And pretty much how this goes together. That just sits on there, and with a little bit of fitting, everything just bolts back together. Alright, thanks a lot, guys.